Welcome to our channel. Let us discuss problem number 11. Draw the isometric projection of a hexagonal prism of side of base 40 mm and height 60 mm with a right circular cone of base 40 mm and diameter 40 mm diameter and altitude 50 mm, resting on its top such that the axes of both the solids are collinear. So at the bottom we have hexagonal prism. Above that we need to place a cone. The hexagon of side 40 mm is given. So construct hexagon, orthographics of hexagon using continuous line, thin line. So 40 mm, 0 degree, 40, 60 degree, 40, 2 times 60, 40, 3 times 60, 40, 4 times 60 is the angle, and join to the base and get the dimensions between all the corners using distance between command. And at the same time we are enclosing this hexagon in a box. Actually the bottom dimensions and top dimensions, left dimensions and right dimensions will be same. So once you get these dimensions for hexagon, start drawing it on 30 degree line, around 50 degree line. Let me take this 20, 40, 20 dimension on 30 degree line. So 20, 30 degree, 40, 30 degree, 20, 30 degree. Then the next dimension is 34.64, 150 degree, 34.64, 150 degree. We have taken term, that is 20, 40, 20 will come on minus 150 degree. 20, 40 and 20 will come on minus 150 degree line. Then we have 34.64 minus 30 degree, 34.64 minus 30 degree. Once you obtain this, find the endpoint of this to get the required hexagon. By selecting the endpoints, you will get the required hexagon. Take axis line, line thickness 0.13 from the intersection. Better you draw a thin line which joins these two corners. The midpoint of this line will be the center of the prism from which we need to take axis line, hexagon height. The hexagon prism of base side 40 mm and height is 60 mm. So 60 is the length, angle is 90. Then switch to continuous line. Anyhow, we have bottom hexagon for a prism. Base prism will have two base, right? So make use of move command, switch on copy, move from base to the top and join the corresponding sides using thick line and continuous line. So this completes the hexagon prism. Let me take this a little bit down, because above this we need to draw the cone. So a cone of diameter, base diameter 40 and altitude is 50. So to draw the cone, We can consider it separately also. We need to draw a square of 40 mm side. Make sure you use a thin line 0.13 and continuous line 40 30 degree, 40 150, 40 minus 150, 40 minus 30. Then the base of the cone is circle. The isometric view of circle is ellipse. So construct ellipse by center point method by joining the corner to opposite midpoint. Go for arc by center point method. Start drawing an arc from the intersection to the so this will be the center, intersection will be center, and this is the center radius. And second arc, the intersection is here. This is the length of radius. Draw another arc. The third arc is from here to here, and final arc is here. Now take axis line, the intersection of these two. So this is the center of, we can see the relationship, a dotted line, which shows is the intersection of these 2 points, the corners of the square. From there, you take axis of the cone. Axis of the cone is 50 mm, so 50, 90 degree. Take continuous line and join like a tangent to the ellipse, end point to the tangent to the ellipse. Now move the cone make use of move command, move the cone from the base center and place it on the top center of the hexagon. While move, anyhow we don't want the copy of this cone, so while moving, switch off copy, move from base of the cone to the top of the prism. You can trim the unwanted lines, the invisible edges, you can trim. These are the rear ends of the hexagon, and construction line also you can trim, but don't delete the axis. Make use of zoom command to trim the small lines also. The interior part of the cone is going to be invisible, so the arc which is coming inside the cone we need to trim. So this is the isometric view of the combination, and make sure it is very thick except the axis line. Select entire thing and give scale command, scale 0.8164 and place it. So this completes the problem number 11. Let's move to problem number 12. A cone of base diameter 30 and height 40 rests centrally over a cube of side 50. So cube of side 50 is very easy to construct. 50, 30 degree, 50, 150, 50 minus 150, 50 minus 30. Then from every corner you take the height also 50, because for cube the all sides are equal. So 50 minus 90, 50 minus 90, and join to the remaining corners. So this is a cube, and above this cube a cone of base diameter 30 mm. So cone of base diameter 30 mm. To construct ellipse of diameter 30 mm, we need square of 30 mm sides. So anyhow we have square of 50 mm. Go for move command. From the center I take zoom See, this is the center. The two dotted line indicates the relationship from that center, and switch on copy and place it there itself, and immediately go for scale factor. The square we needed is cone base diameter is 30 divided by 50 mm square we already having, so 30 by 50, and the center will be same, so choose this as a center. So once you get a square of 30, join the corner to opposite midpoint to get the center to construct the ellipse. Go for arc by center point method, draw an arc, the intersection will be the center. So this is the base of the cone. Now from center you take axis length. The height of the cone is 40 mm. So take zoom. The center of this base we need to find. Take axis line. So this is the horizontal line and this is the vertical line. So intersection of these two is the center. Height of the cone is 40 mm. So 40 mm 90 degree. From there you choose continuous line, join tangent to the ellipse. Trim the unwanted edges, is going to be invisible, and these are all construction lines. And this is also going to be invisible. So this is the isometric view of the combination. Make it thick, convert into isometric projection by taking scale 0.8164 and place it, and axis should be 0.13 thick. So this is the solution for problem number 12. Let's move on to problem number 13. A cone of base diameter 40 and height 50 rests centrally over a frustum of pentagonal pyramid of base side 45 mm and top side 35 mm, height 55 mm. Draw the isometric projection of the combined solid. So we have frustum of pentagon pyramid. Base side is 45. So let me construct a pentagon of side 45 first. 45 0, 45 base side is 45. Take length 45 0 degree, 45 72 degree, 45 2 times 72, 45 3 times 72, 45 4 times 72 is the angle. Then rotate this pentagon in such a way that one of its edges is vertical, and get the dimension of this using distance between command. So distance between, I take zoom from, while if you choose the distance between, after taking every dimension you need to right click in your mouse. Right click after getting every dimension, you should right click in your mouse, otherwise this type of caution box will come, dimension cannot be placed. So anyhow, the bottom dimensions and top dimensions will be same. We have enclosed this pentagon in a box. Let's consider this as a 30-degree line. The first dimension is 42.8 at an angle 30 degree, 26.45, 30 degree, 36.41 will be at an angle 150 degree, 36.41 at an angle 150 degree. Then 26.45 minus 150 degree, 42.8 minus 150 degree, and this is 13.91 minus 30 degree, 45 minus 30 degree, 13.91 minus 30 degree. Now you take thick line, 0.5 mm line, search for the endpoints, join the endpoints. So this is the pentagon, base pentagon we got. So now this is the frustum of pentagon pyramid. Take center by joining, find the center by joining corner to opposite midpoint. Corner to opposite midpoint. You take another corner and join to opposite midpoint. Now measure these two distance from this midpoint to this intersection is 30.90, so 97. From here you take a thin line, 30.97 at an angle 30 degree. From there you take axis of the frustum of pentagon pyramid. The axis of the frustum of pentagon pyramid is 55. So 55, 90 degree. Now since it's a frustum, you will get top pentagon also. Choose the bottom pentagon, go to move, switch on copy from base center and place it on top center, taking this endpoint as a reference, and immediately go for scale. The top pentagon side is 35, so scale factor will be 35 divided by original length is 45. 35 divided by 45, and place it on the endpoint. Join the corresponding corners using thick line, and line type should be continuous. Anyhow, the front three corners are enough. The rear end is going to be invisible. Above this, a cone of base diameter has to place. A cone of base diameter 40. Just now we discussed how to construct the cone of base diameter 40. 40, 30, 40, 150, 40 minus 150, 40 minus 30, and join the midpoint opposite corner, join midpoint to opposite corner, and construct ellipse by midpoint method using arc by center point method, arc by center point command. This is the first arc, this is the center, and this is the radius. Second arc, the intersection of these two will be the center for third arc. And finally, this is the center, this is the radius. Go to axis line, the intersection of this diagonal corner and this corner, intersection of these two. If you're finding difficulty, means go to line, thin line, just join these two corners. The midpoint of this will be the center of the cone. From there you measure the height of the cone is 50, 90 degree. Join a line type should be continuous from the end point to the tangent to the ellipse. Now we move this cone, move this cone using move command, place them exactly on the pentagonal pyramid and trim the unwanted edges. Take zoom and trim the unwanted edges. The construction lines are not required and you need not to do any dimensioning for isometric projection. You can take zoom further to get clear picture. Give fit and select all. This should be thick, so make it 0.5 mm thick. Convert to isometric scale. Take scale 0.816. So this is the solution for problem number 13. Thank you.